And before I start, so while you get to page 27 and you get a bunch of highlighters ready to go if you want to follow along with what we're doing, I want to give you, this is a very static, all these are so static, they all look the same. And technically these curves do not look the same, okay? So this is my best way to show you how things can change if you were to have a bigger or a smaller standard deviation. Okay, so I'm just gonna move these. So this slider here represents the standard deviation of a curve. Okay, so watch what happens if I were to increase the standard deviation. See how it gets flatter, and the scale, like the scale that we're going up by, because just make sure you follow along. The distance between, this is your mean here. The distance between the mean and one standard deviation to the right is 1.84. But if you increase that, oh, I can't, can I do more? No, yeah. So the more you increase it, the flatter your curve gets. So you should see that correlation, right? A big standard deviation means data is spread out. So you're making your bars bigger to account for that, okay? A smaller standard deviation would actually bring closer those bars closer together, and it would make the curve steeper. It's getting kind of crazy here, this one, anyways. But I think you get the, I hope you get the point there. That's really what's happening here. And unfortunately, it's really hard to draw these to scale. Okay? All right, so let's bring this one down. Come on. It's not that hard, is it? There we go. So what happens, let's say you had, this is the average, right? The mean that's always at the center of your curve. Remember, this is only if it's normally distributed. Not all data in life is normally distributed. I can show you some of my previous classes. I could show you the graph of our final averages, and they're not normally distributed. They might be actually lopsided, or like you might have like two waves like this. So it varies, but when we talk normal distribution, this is what we're looking at. So if you change the mean, watch what happens. The whole curve shifts along the x-axis. So if you have a big average, you're going to be higher up. If you have a lower average, you come further down. So that's what I always want you to think of in the background. And we have very small numbers here. Sometimes these are in the thousands and the hundreds of thousands, maybe even millions, right? So it doesn't matter what the x-axis is, but whatever the average is, that kind of tells us where the center is of this curve, and then it's symmetric around the mean, okay? So that's something to remember. I kind of alluded to this before. So now you have a bit of a visual, so you know that it's not always static like this, but this is the best we can do, okay? So on 27, I asked you to graph this. So what I'm looking for is labels, right? You want to make sure you have labels. You want to make sure you have the percentages. And I do look at the curve as well. So if it looks a little weird, like a beach at the wave, sorry, a wave at the beach, sorry. Right? If it looks like one of these, like that's not a normal distribution, right? So you want to kind of have it like this. So I always tell my students, start with your middle, put a point down there, and then go to one side and then to the other side, and that usually works out pretty good. Do not touch the x-axis here. I also expect you to either memorize or just have those percentages written down on your study sheet, because you're going to need them, okay? Another thing is you start with your average, mu, right? And then we add a standard deviation every time we move to the right. And we subtract a standard deviation every time we go to the left. Okay? So, and then if I do ask you the graph, folks, because soon we're going to use the calculator. If I ask you the graph, I expect you to draw from the graph if I ask you questions down the road. Okay? So just a couple here. Let's do them together. Oh yeah, I do have it here. One thing that I forgot here is the z-score. Sometimes I ask you to do that. So let's write this down. Okay. 0, 1, 2, 3. That's as simple as that. What you're going to realize is that later on, we will have, like, for example, in this case, it's the volume. We could have a volume anywhere along this x-axis that is not necessarily one of these values we wrote down. Same with the z-score. It could be that you have a z-score of 0.5 or 0.73, right? Or 1.9. Or you could have a z-score of negative 2.4, somewhere in here. So you'll have different numbers, not necessarily these ones that show up here, but these are a good reference for us. Okay? All right. What percentage of cans will have a volume of more than 360.5 mLs? It shows up here. So it's basically just these two numbers added up because it's more than that. So everything to the right. So I would like you to show me the work if you have a graph. 2.5, 2.50%. Just make sure you have the units there. What percentage of cans will have a volume in between these two? So it's 349 right here. I'm going to use a pencil. 349 to 363. So it's everything that's in between these two volumes. And if you add that up, and some of you already did that, so way to go. I'm just reviewing here. That is 97.35%, correct? Is there a different way of doing this? Yes, and I want you to know that, okay? Just make sure you write this down. 100%. 100% is the entire curve, okay? From end to end. I will subtract 0.15 from it, and I will also subtract this tail here. So if you subtract these two, actually three sections, right? So 1, 2, 3 from 100, you get the same answer. Okay, that is 97.35. So regardless of how you do it, this is the direct way. This is the indirect way. That's all. You just have to be comfortable with that. D. These ones are a bit more challenging, so it's usually going to have 2 marks attached to this type. Okay? If the company removes cans that have a volume that is less than this and greater than 363.25, not the percentage, but actually how many cans would be removed after producing 25,000 cans. Okay? So you first have to figure out percentage being removed. If you already have this done, don't write over this, right? You might have looked at my key. This might be slightly different. Percentage being removed would be anything less than 352.25 would represent anything, sorry, you can't see that, but this is the value in question. So anything less than that is removed. So we have the percentages right here. Okay, so I'm going to go 0.15 plus 2.35 plus 13.5, right? So I've removed that. This is technically less than that first limit, plus anything that's more than 363.25. It happens to be right here. So that little percentage is 0.15. I add that to my ongoing tally, right? So when you add up all those percentages, you get 16.15%. So that would get you a mark already. That is the percentage being removed. Number of cans, you just take that, divide it by 100. Don't round, use all decimals, and just multiply by the number of cans. Okay, and that would give you, I have 4,037.5, which is approximately 4,038 cans. From a business standpoint, you usually round up in this scenario, right, to be safe. These two I haven't done yet. I don't know if you tried it, but it says calculate the z-score, and it emphasis on the calculate. I will do that here, and then we'll go back in our notes and do it one more time. Calculate the z-score for a can with a volume of 353.5. This is the formula. The z-score is x minus average divided by standard deviation. This formula is on page, I'll tell you later. I don't remember right now. But what is x? X is the value in question. So 353.5. And keep in mind this could be negative. It's okay to have a negative answer. What is my average? That was way at the beginning of this question, which is 355. Make sure you do that first, and then you divide by the standard deviation, which I'm told is 2.75. So really, you know all the information. You know every single piece of info to do this one. So when you subtract, you get negative 1.5 over 2.75, and that is negative 0.55. Z-scores have no units. Remember that one. Z-scores have no units. What does it tell us when you look at this, folks? What do we know? Is a can with this much volume above or below the mean? Below. How do we know that? The sign. And it's below by half a standard, half a z-score, half a standard deviation. Let's verify that. Let's go up here. If this is 355, then 353 is somewhere in here, right? So it makes sense that it's negative 0.55. It makes sense. Okay. So verify that. That's just weird stuff, right? Yeah, I know. But, okay, let's give you some context here. I always go back to when my little boys, they were like, I could fit them like a burrito in my arm, right? When they were born. The doctor said, your baby's weight puts them at a z-score of -1 or -1.2. I would, knowing this, I would be like, uh-oh, my baby is underweight. And minus 0.5 would be not extremely underweight, right? Like if you're at -2.5, -2.7, now you're really far from the mean, right? This is what a baby should weigh. -2.7 or something, you would be very, very underweight, which is a big problem with newborns, right? So to give you some perspective, doctors use this all the time. I'm telling you, maybe one day you'll get to that point, you'll be like, oh yeah, I know what you're talking about. They don't think you know, right? But sometimes, like I did know what they were talking about. So I saw the chart, so it was pretty cool. Next, F. Calculate the volume. So you want calculate again. That usually means there's some sort of formula or process involved. The volume of a can with a z-score of 1.23. We know already that this is going to be above the mean, right? It's going to be more than 355. Okay? In fact, can you go up with me? I know I'm going back and forth and you're kind of getting tired of that, but if this is 0, a z-score of 1.23 would be right about here. So you expect it to be more than 357.75. Okay, let's calculate that though. What formula am I going to use? It's this one. Z times standard deviation plus mean. Yes, thank you. That's the formula. Okay, so I know that my z-score is 1.23. And my standard deviation is 2.75. That's given to me by the question. And I know that the mean is 355. And that gives you, this part right here is 3.3825. And I add 355 to it. That would give me 358.38 ml. Okay, so I'll do it one more time in our notes because I skipped that yesterday and I'm aware of that. I just didn't want to overwhelm you too much. I know it was a lot of information yesterday, almost an hour of just blah, 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 right? I know, it's painful. You were probably thinking of Gladys over at the end of that lesson, right? Anyways, let's go to 26 here. Again, I ask you to calculate, not just to estimate, calculate. Calculate the z-score for a male with a height of 181. Okay, so we're going to do that. This is the formula for z-score. Page 26. The x value here is 181. The average, I was told already at the beginning of this question, was 177. The standard deviation I was also told is 2.5. So when you subtract these two, you get 4 over 2.5, and that would be positive 1.6. So if your height is 181 centimeters, that is the equivalent of a z-score of 1.6. So we know this is above the average, and it's actually significantly higher than the average because it's more than one standard deviation. So what does this tell us? I'm going to cut it here. A height of 181 centimeter places you at 1.6 standard deviations above the mean. Z-score is more like a comparison thing. How does it compare to the rest? Okay, how does it compare? So if you write one of my tests and you calculate your z-score and you find out that it's 2.5 positive, you're like, oh, based on the average, I'm like 2.5 standard deviations above the average in the class. Right? So you're definitely, compared to everybody else, you did well. If your z-score is negative 2.5, you know that you scored less than the average. Obviously, I'd have to tell you the average for you to be able to figure that out, but that is the case. Okay. Determine the height of a male with a z-score of negative 0.4. So determine. So you want the height. So that's x is equal to beta times z plus mean. And this is your standard deviation, which we know is 2.5. The z-score is negative 0.4. So make sure you write this down. So there is a negative there, so you need to be aware of that. Plus 177, that's my average. This, if you multiply it, you get negative 1. Plus 177. Negative 1 plus 177 is 176 centimeters. There you do have units because you want to know the actual height. Note, z-score is negative, so height is below the mean. All right. So I'm going to give you a short AC. I'm going to tell you that if I ask you to make a curve with it can be very, very basic. I'm not going to mark you on the curve necessarily. I'm going to mark you on the answers that follow. Okay? So just close this for now.